So I want to go back briefly now that I've got a calculator open to show you some tips and tricks on using the calculator to solve some of these. So like I said, it doesn't matter which order you do it. You can square first, specifically looking at A, sorry. You can square first or take the fifth root. If you want to take the fifth root, there's a special button. If you go to math and then the fifth one down, see it's got a little X and then the square root button. So that's telling you can input whatever root you want. The key with that is you have to put the number first. So if I want to take the fifth root, I'll have to hit 5 and then go to math and pick that. And so now you can see it's taking the fifth root. So I'll take the fifth root of 32, which is 2. And then you can take the fifth root of 243 to see that that is also a perfect fifth. So you can do that way to find out if something is a perfect root of whatever you're looking for. If you want to raise something to a power, you can actually do that as a whole. So if we're taking negative 32 over 243, we're raising it to the 2/5. You can actually do that here. You just want to make sure to put it in its own set of parentheses. And so then checking here, we should get, okay, maybe not. I'll have to double check some things. It might not have liked my fraction there. On my other calculator, I can normally do that. So I don't know why it's not working here. What happens if I do, sorry, I want to double check something here. What if I raise that to the 0.4 power instead? Oops, I don't want that. I want the 0.4 power. Will that give me what I want? That'll give me what I want. Often I'll have to see what the difference is there. But so I raised it to the 2/5, which is 0.4 as a power. And there it's giving me the right answer of 4 over 9. So you should be able to do that on your calculator as well. I'll have to double check some things there. But you should be able to use your calculator to find pretty much anything that you need here. So going back to our problem, we just found the heart rate of the elk was about 60. So if we want to find the ratio, so find the ratio of H&M for the, looking at the problem, 2 animal species differ in mass by a multitude of 10. According to the model, about what % of the smaller animal's resting heart rate would you expect the larger animal's resting heart rate to be? So we're setting up a ratio. Find the ratio of H of M for the larger over the smaller. And let 1 represent the mass of the smaller animal. So if we're estimating it to be 10 times larger, you can see those are going to cancel out. And we'll just be left with 10 to the negative 1 over 4th. What that actually is, that negative is telling you to take the reciprocal. So it's actually 1 over 10 to the 1/4, which ends up being about 0.56. So you would expect the larger animal's resting heart rate to be about 56% of the smaller animals. Similarly, we can rewrite this one as 241 and then over m to the 1/4, or 241 over the 4th root of m, just a different way that we can rewrite this problem. So in part B, the exponent is negative. Like I just said, are the results consistent with the meaning? Yes, because it should be the reciprocal of the power. So the negative exponent, you take the reciprocal of the power. So whatever that power is, you switch where your base is. So x to the negative 2 ends up being 1 over x squared. Or if you have 1 over x to the negative 3, you take the reciprocal, will end up being x cubed. And that's it.